So we're now done the first two steps of the problem. I've recopied the question itself and I've recopied our YC and our YP from the first two steps. So now for step 3, we're going to plug YP into the DE, and this is where we're going to find these unknown coefficients. So in this case we'll find A and B. Before we can plug in, we need to get our ingredients ready. So let's write down YP. It's a plus bx squared e to the 2x. And in our next step, we're going to take the derivative of this. So looking at this second term here, we're going to be applying the product rule. And let's think of the product as being bx squared times the exponential. Okay, so let's work out yp prime. A is a constant, so its derivative is 0. And then applying the product rule to the second term here, we'd have bx squared times 2 e to the 2x plus 2bx times e to the 2x. Now, because we've got another derivative coming up, what I suggest is that we take a moment just to rewrite yp prime in a little bit nicer way. So this first term here, we could think of that as 2bx squared e to the 2x, and the idea here would be maybe it's easier to factor out that exponential. So let's pull the e to the 2x out at the back, and we'd have 2bx squared plus 2bx in these brackets here. Okay, so what I'm going to do is I'm going to put a box around the simplified version of each function so we know which one we're looking at, and then from there let's try yp double prime. So we got another product rule coming up. We're going to copy all the stuff in the brackets here. That gets multiplied by 2 e to the 2x, and then we go plus, we need to take the derivative of the first factor, so 4bx plus 2b, and multiply by the second factor there. Okay, so again, let's try to get this simplified. What I would do as an intermediate step here is looking at that first term, let's actually multiply just the 2 through. So I'm going to cross out this 2 here. I'm going to multiply it through the first set of brackets. So we'd have 4bx squared plus 4bx. So we'd have all this stuff here still times the exponential, and that way we can factor the exponential out. So pulling the e to the 2x out at the back, what would we have? We'd have 4bx squared plus 4bx, all times the exponential, and then we've got a couple more terms coming up. We've still got plus another 4bx plus 2b times the exponential. All right, so let's write a fully simplified version of this, just right beside here. If we simplify those coefficients, 4bx squared plus 8bx plus 2b, all times the exponential. Okay, so I'm going to put a box around this one saying that's the one that we're going to want to be working with. As we plug this into our DE, it's really going to pay off to have simplified expressions to be plugging in. Maybe one other thing I would point out here is in looking at YP, these brackets that we introduced, those were not mathematically necessary. We just introduced them so that psychologically we could understand how we would be applying the product rule. But it's probably going to make life easier when we plug in, just not to have those brackets there. So there we go. We've got nice simplified versions of YP, YP prime, and YP double prime. So we're good to go in terms of plugging into our DE. I'm going to rewrite the DE just for clarity. So let's plug YP into the DE. When we see this Y double prime here, we're going to be plugging in YP double prime. So let's take this expression here and plug in. Then we want to go minus 4 times yp prime. So plugging yp prime in here, we've got 2bx squared plus 2bx times the exponential. Great, and then continuing to plug in, we're going to go plus 4 times yp. We definitely need brackets here so that all of yp gets multiplied. So it's a plus bx squared times the exponential. The a is not multiplied by the exponential. And all this stuff is equal to 12 plus 2 e to the 2x. Our plan over the next few steps is to expand the left side, and we're going to collect like terms. So let's multiply everything in the first set of brackets by the exponential. For the second set of brackets, it's always a pain to deal with a triple product like this, so what I would normally do is just cross off the exponential, put it at the front, and then think about multiplying the brackets here by negative 4 e to the 2x. That always makes life easier. So we'd have negative 8bx squared times the exponential, and then watching our signs, it would be minus 8bx times the exponential. Okay, then one more set of brackets to go, plus 4a plus 4bx squared e to the 2x is equal to the right side. Okay, so now I'm starting to feel like we're getting somewhere. So let's try to collect the like terms. Let's look at all the terms that have the form x squared e to the 2x. So there's one of them. There's another one. And we've got one more down here. Okay, so overall, how many of those do we have? We've got 4b minus 8b plus 4b. So that's 0. We've got 0 x squared e to the 2x's. So that's great. I'm going to cross these off. We've dealt with all those terms there. Okay, let's move on to the terms that look like x e to the 2x. So there's one of them. And there's another one. So we've got 8b of them minus 8b of them. So overall, 0. We've got 0 x e to the 2x terms. Okay, and we can cross those off. So now 5 terms have been crossed off. There's just 2 left. We've got plus 2b e to the 2x plus 4a, and that's equal to 12 plus 2 e to the 2x. All right, so these first 2 terms here, since they're 0, they don't really need to be written down. I'm going to erase those. So we've now expanded our entire expression. We've collected all our like terms and just simplified that left side as much as possible. So now what we're going to do is we're going to match up the coefficients. So since we've got an equation here, we must have the same number of constants on both sides of the equation. 4a must be equal to 12. And in a similar way, we can say, well, we must have the same number of exponentials on each side of the equation. So if we look at our exponential terms, we've got an exponential term on each side of the equation. On the left side, the coefficient is called 2b. On the right side, it's called 2. Well, 2b must be equal to 2 in order for this equation to be true. So we're really getting 2 pieces of information here. Each type of like term is going to give you 1 piece of information. So the constants are telling us that 4a is equal to 12. The exponential terms, the e to the 2x terms, are telling us that 2b equals 2. All right, so this is a pretty friendly equation or system of equations to solve. The top equation for a equals 12 tells us that a equals 3. And bottom equation, if 2b equals 2, then b equals 1. So there we go. We found the values of a and b, and we can write down yp. All right, so let's finish our workup over here. Let's just recall yp. So I'm just looking back to over our previous work in the problem. In step 2, we said yp was a plus bx squared e to the 2x. So plugging in the appropriate constants now, we know that a is 3, and we know that b is 1. So there is our final version of yp. So that is step 3 done. Right, step 4, we're going to build our general solution, y, just by adding yc and yp. Okay, so looking back to step 1, you can use either version of yc here. It doesn't really matter which one you use. The factored form is usually pretty nice for a final answer. So I'll say there's our yc, and then we're going to add on our yp, which we've just discovered. Okay, so the complementary solution here, this is the one that has the unknown coefficients. It's got the unknown constants in it. So that's what's making sure that we're capturing all possible solutions to the DE, whereas the particular solution is required to have exactly these coefficients. The coefficients have to be 3 and 1. They can't be multiplied by anything. They can't be changed in any way. And this part here, this particular solution, is what ensures that the right side of the DE comes out to exactly what it's supposed to be. Okay, so there we have our general solution. And if there were initial conditions in this problem, we would deal with them in step 5. But fortunately, no initial conditions to deal with in this particular problem. So here we have our general solution. We'll put a box around that because we did a lot of work to achieve that. So there we go. Thanks for watching, and we'll see you in the next video.